Okay, let's do some isolating of triangles. So I'm going to go down here quickly and let's have a look here. We've got BT, that's what we want to prove. BT over BP is equal to AT, that's what we want to prove, over PT. And we're going to now start identifying triangles. Okay, so let's have a look. So if we go down, let's have a look here. If we go across, we've got BT, or BPT. It's a big triangle. And then PAT. So if we go down, let's just try going down. We've got B first, then P, then T, and that is a triangle. BPT is the big one, and then you've got here APT, which is also a triangle, APT. So by going down, you got a triangle there. Okay, so that's one way of doing it. Now let's make the angles. There's B, P, and T, A, P, and T. I'll always put them in alphabetical order to try and see, and then try and match the angles. It always works brilliant there. We'll have a look at this. If we can see what we've got B, P, and T, so that's T1 and 2. Then we've got APT, so A takes on a 1, T takes on a 2. Now let's match make. Let's see, how do we match make this? We'll have a look. P is equal to P, it's common. Then we've got, because this is a tangent, we've got T2 is B. You see that there? So T2 is B. So we've linked those two, and then the weakest link would be A1 is T1 plus T2. So we're going to use that as our third reason. So let's construct a proof quickly. We can say, now watch this. In triangle, if you go BPT, if you go triangle BPT, you must connect the angles in exactly the same way, BPT. And you'll see who goes with B is T, T2. Who goes with P is P. And then we've got who goes with T is A. So that's TPA. Okay, so be very, very careful with that you get the order of that angle B goes with a T, so that B must go with a T. P goes with P, so no problem, those are equal, and then T goes with the A, T goes with the A there. Now let's prove this here. So we can say number A, what do we know in the two triangles? Okay, with BPT, well, if you look at that, we've got B is equal to T2 from the tan chord, which is quite nice. B is equal to T2 from the tan chord. So let's write it. B is equal to T2 from the tan chord theorem. Okay, that's the first piece there, from the tan chord. So B is equal to T2. Then we've got angle P being common. It's a common shared angle. So P is equal to P common from both of the triangles there. And C in the third one would be then T1 plus T2 is equal to, if you look at that, it's equal to A1 there. That's the weakest link, A1 there, A1. And that we just do from the sum of the angles of a triangle there, sum of the angles of a triangle there. Okay, and then we can then conclude that the triangles are similar. So therefore triangle BPT is similar to triangle TPA, 3 pairs of equal angles. Remember, if we go back and check there, we've got T2 is equal to B, which is this one. T2 is equal to B, this line there. Angle P is equal to angle P common, and then A1 and T1 plus 2 would be equal. A1, T1 plus 2 equal via the sum of the angles of a triangle there. Then all we do is frog face, BP over TP, BP over TP, PT over PA, there we go, and then BT over TA, BT over TA. So we've proved that. Now all we have to do is, let's go and see what we wanted to prove. If we got that there, if we go up here, let's put a little block around it and copy it and bring it down, so that we can see what we have to deal with here. So paste it there. There we go. So let's bring him in there. So let's see, what do we have in terms of this thing that we want to prove. We've got a BT, we've got a TA, which is BT, TA, BP is there, and PT is there. So if we extract these out, now look at this. You've got BP divided by PT, or TP there, is equal to BT over AT. If you bring these out and make TAAT. Now, how do we get to then this? Okay, well, let's see. We've got a BP at the bottom, and this is a very awkward one here. BP at the bottom, and what we could do is we could swap these two first. Let's see that. So let's see, we've got BP over BT is PT over AT. There we go. So swap those, and look at that. Now you've got the BP and the BT and the AT and that, and all you now have to do is you just simply go and swap those. So you can say, therefore, BT over BP is equal to AT over PT, and there you've got it there, and you've swapped that, and you've got what you want. So a little bit of tricky things here. First, interchange those two, and then invert them both. Okay, swap them around, and you can do it because look at this. 3 over 4 is going to be 6 over, if you multiply 6 over 8, 3/4 is 6 over 8, because if you think of that, if you divide 6 by 2, you get 3, 8 by 2, and you can say it's 4 over 3 is 8 over 6 as well. You're most welcome to do that. So it works in this context as well. Well, guys, I hope you enjoyed similar triangles. They're very lacquer things to get good marks on. And so I trust that you master this section, and then let's continue in the next lesson with more wonderful mathematics on Moby School.